Dear students, last time we have seen what are third order reactions, examples of third order reactions, rate constant of third order reaction, and the characteristics of third order reaction. Let us see today the complex reactions. Before going to discuss the important complex reactions which are included in our syllabus, let me tell you at first the classification of chemical reactions. As per classification of chemical reactions are concerned, taking place of course in single step or more than two steps. Chemical reactions are classified into two: simple reactions and complex reactions. So what are simple reactions? The chemical reactions which occurs in single step are known as simple reactions. Simple reactions are also known as elementary reactions. So, the elementary reactions or simple reactions are those chemical reactions which occurs in single state, which takes place in one step only. So, a chemical reaction which occurs in one step is known as simple reaction or elementary reaction. Let me give you few examples of simple reactions or the elementary reactions. A reaction between HCl and NaOH solution is a very common example of simple reaction. Here we will see that when we mix HCl solution with NaOH solution, we get NaCl plus H2O. This reaction takes place in a single step, occurs in a single step, or we can say that this reaction goes to completion in one step. So when we look at this, we will see that these are the two reactants. When these two reacts with each other, we get product. So when the reactants react and gives directly products without involving any intermediate step, any other intermediate step at that time, that reaction is known as simple reaction. So we can have so many examples of simple reactions. Without going into the details of simple reactions, let us see what are complex reactions. The complex reactions, name itself indicates that the chemical reactions which takes place in two or more than two steps are known as complex reactions. And for your information, most of the chemical reactions are complex reactions. What does it mean? It means that the whatever desired product which we want in most of the chemical reactions we does not get it directly on interacting the required reactants. What happens? Actually, in most of the chemical reactions, when we mix reactants, reactants initially undergo certain chemical reaction and gives the new products, so called as intermediates, short-lived products, intermediates rather, and later on those intermediates are converted into either few more intermediates or the products. So in this way, a chemical reaction which takes place in either two steps or more than two steps is known as a complex reaction. And the examples of complex reactions are many. Say for example, in case of thermal decomposition of acetone, the thermal decomposition of acetone takes place in two steps. In first step, acetone is converted into methane and formaldehyde, and these two intermediates later on, the formaldehyde, one of the most important intermediate in this case, is later on converted into carbon monoxide and other products. So, in short, what are complex reactions? Complex reactions are those chemical reactions which occurs in either two steps or more than two steps. So, how can we define a complex reaction? A complex reaction is a chemical reaction taking place in two or more than two steps is called a complex reaction. Now, as per classification of complex reactions is concerned, complex reactions are of three types. Number one, opposing reactions. Number two, consecutive reactions. Number three, parallel reactions. Number four, chain reactions. So, complex reactions are of different types. The main complex reactions are opposing reactions, opposing or reversible reactions. Second important type of complex reactions, consecutive or sequential reactions. Third type, chain reactions. Fourth type, parallel reactions. So these are the four important types of complex reactions, or the four important classes of complex reactions. Reversible reactions, or opposing reactions, or counter reactions. Sequential or consecutive reactions, chain reactions, and parallel reactions. In our syllabus, we have only these two. opposing reactions and consecutive reactions. So let us see at first what are opposing reactions or what are reversible reactions. Reversible reactions or opposing reactions are those chemical reactions in which the products generated in a chemical reaction react and the original reactants are generated. In other words, a chemical reaction which takes place in both the directions, forward direction as well as backward direction, are known as reversible reactions or opposing reactions. So what are opposing reactions or reversible reactions? The chemical reactions which takes place at a considerable rate, at a remarkable rate in a forward direction, and at the same time goes in backward direction at a remarkable rate, are known as opposing reactions or reversible reactions. So the opposing reactions or reversible reactions, name itself indicates that goes in both the direction, forward direction as well as backward direction. So in short, a chemical reaction which occurs in forward direction as well as backward direction is known as a reversible reaction. So let us see few examples of reversible reaction. The important examples of reversible reactions are: number one, the muta-rotation of alpha D-glucose into beta D-glucose is an interesting example of reversible reaction. Alpha D-glucose, beta D-glucose. This interconversion, the conversion of alpha D-glucose into beta D-glucose and the conversion of beta D-glucose into alpha D-glucose is a very good example of a reversible reaction or opposing reaction. Here what happens? Alpha D-glucose is converted into beta D-glucose. This reaction, this conversion, the conversion of alpha D-glucose into beta D-glucose is forward reaction, and beta D-glucose is converted back into the original reactant alpha D-glucose. Is a backward reaction. So this reaction occurs in both the direction, forward direction as well as backward direction, and therefore is known as a opposing reaction. The second important example of opposing reaction is the conversion of gamma hydroxybutyric acid into lactone. The conversion of gamma butyric acid, gamma hydroxybutyric acid into lactone, CH2OH, CH2, CH2COOH, gamma hydroxybutyric acid, gamma hydroxybutyric butyric acid. 1, 2, 3, 4. Gamma hydroxy, gamma, alpha, beta, gamma, gamma hydroxy butyric acid is converted into lactone, O, CO, CH2, CH2, C, CH2, C, H2. This ring is known as lactone ring. Let us write it like this: CH2, lactone. Okay. A five-membered ring in which oxygen is there is known as lactone ring. O, CO, CH2, 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 O, lactone. So this interconversion, the conversion of K2 alpha hydroxy butyric acid is converted into lactone, and lactone is converted back into the original reactant alpha hydroxy butyric acid, sorry, gamma hydroxy butyric acid. So this is what the another example of reversible reaction or the opposing reaction. With this, I stop here. Next time we will see the rest of the details. Thank you. Thank you very much.